Hey guys, welcome to our lesson on Math 112, Section 8.2, the law of cosines. So the law of cosines and law of sines are very similar ideas. Their derivation is very similar as well. So let's quickly go through the derivation of the law of cosines. This is not something I'm going to ask you to ever do or anything like that, but I want to show it to you guys so that you guys understand kind of where it comes from and how it works. And so we start off with the non-right triangle, right? And that's not a right triangle, no matter what it looks like. So we have our side lengths here, B, A, C. I'm giving myself a little room on that C because I'm going to write some stuff in there. Again, we give ourselves this perpendicular height line here. Since that side's A, this is angle alpha, angle beta. Now what I'm going to do here that's different is I'm going to label this point here P. I'm going to label this point here where this height comes down is the point Q. And this point over here is R. That's going to be something that's going to be really crucial in trying to develop and derive this law of cosines. Okay. So what we can do here is let's just focus on alpha. Okay, and this works. You can just change things around and do beta and gamma, and that's why this will apply to everything, and we'll kind of go through that in a minute. So first off, cosine of alpha is equal to, well, cosine is adjacent, which the adjacent side here is side PQ. So we're going to write that as, we're just going to say is PQ over B. Now, when we do that, right, we're not saying P times Q. This is simply side PQ. So whatever that length is. We can do some fancy algebra. In other words, multiply both sides by B. And we get that PQ is equal to B times cosine of alpha. Okay. So we have that. Now, another thing we're going to need is the sine of alpha. Sine of alpha is nice and easy. Sine of alpha is H over B. Again, multiply both sides by B, and we get, this case, it's H is equal to B times the sine of alpha. Okay? Now, the only other thing I want to look into is what is QR? QR is simply equal to C minus PQ. Okay? So these are the base elements of what I need to derive this formula here. And what it's really going to come from is very simply, is it's going to come from focusing on this right triangle here. So the triangle from this point here down to Q over to R. And we're going to use the Pythagorean theorem, which tells us very simply that A squared is equal to H squared plus QR squared, right? Which makes sense because it's simply the leg squared plus the leg squared equals the hypotenuse squared. Okay, so what I want to do now is I'm going to slowly, I'm not going to do a ton of substitutions. I'm going to slowly substitute in values for these things. First thing I'm going to substitute in is QR. Okay, so we have that A squared equals H squared plus, so instead of QR, we're going to use that it's equal to C minus PQ squared. Okay, so that was using this fact here. Now, this next round, I'm going to use both of these facts, that PQ is equal to B cosine alpha, and that H is equal to B sine alpha. And that gives me the expression of A squared equals, instead of H, I'm going to say B times sine alpha. That's getting squared. Plus the quantity C minus, and instead of PQ, say B times cosine alpha. And that also is getting squared. Okay, so we're making some progress. Now what I want to do is I want to deal with these parentheses. I want to get rid of all these parentheses here. by simply, in the first piece, the b sine alpha, by distributing my squared, and in the second piece by multiplying that out, by expanding that. And so what I end up with is a squared equals b squared times sine squared alpha plus, and then if I look over here, if we need to, right, we can think of this as some side work, right? We have c minus b cosine alpha times c minus b cosine alpha, and I have to FOIL this. And when I do, I get the lovely expression of c squared minus 2bc times cosine alpha plus b squared cosine squared alpha. So all I did is I just kind of multiplied things out. I just expanded things, and we got this. So now what I'm going to do is I'm going to rearrange two terms. I'm going to take this term and this term, and I'm going to put them next to each other. And I'm going to do one more thing. I'm going to factor out that b squared. Notice both of these two terms I've underlined in green are b squared times something. And so I get a squared equals b squared times sine squared alpha plus cosine squared alpha plus c squared minus 2bc times cosine alpha. Now you may be able to see kind of where this is headed, right? And this lovely little thing here is 1 from the Pythagorean identity, right? Sine squared alpha plus cosine squared alpha equals 1. So we get our final statement of a squared equals b squared plus c squared minus 2bc times cosine of alpha. Okay. And what's really cool is we can flip anything in here to get our three alternate versions. And so this would just be kind of rotating the triangle. So you could get that b squared is equal to a squared plus c squared minus 2ac times cosine of beta. C squared is equal to a squared plus b squared minus 2ab cosine of gamma. So those are our three different versions of the laws of cosine. Again, not something you need to memorize, something you have on the formula sheet. Make sure you guys just are, what we're really going to work on this lesson is how to work with this and what we can do with it. Now, another really important thing that you're going to need to do, so these three give us a nice, easy way to find a side length, given we know two side lengths and the included angle. So what that means is essentially we know this length here, we know this length here, and we know the angle from between them. Okay, so this would be side, angle, side. Now, we can use this in other ways too. And one of the things that's really useful is to solve this expression for cosine of the angle. And so if we look at our first version here, I'm going to go off and do this on the side. So I have a squared was b squared plus c squared minus 2bc times cosine of alpha. Because this is negative, I'm going to add 2bc cosine alpha to both sides. Plus 2bc cosine of alpha. But I'm also going to subtract a squared. Okay, so these are gone. The a squareds are gone. This has gone over here. What I'm left with is 2bc times cosine of alpha equals b squared plus c squared minus a squared. So to isolate this for our cosine, we just divide by 2bc. Right? Those cancel. And I end up with cosine of alpha is equal to b squared plus c squared minus a squared all over 2bc. Okay, so by just manipulating these law of cosine equations, the cosine of alpha, b squared plus c squared minus a squared over 2bc. Cosine of beta, a squared plus c squared minus b squared all over 2ac. And cosine of gamma, a squared plus b squared minus c squared all over 2ab. So these are kind of the 6 useful versions of the laws of cosine that we're going to be applying throughout the lesson today and things that you should have. Now, on your note sheet, I believe it only has the first 3 laws of cosine where we have a squared equals b squared plus c squared minus 2bc cosine alpha. It doesn't have these isolated ones for cosine. So that may be something that you may want to do. You may want to have that written down on a note sheet or something like that. So just make sure you guys are aware of that. But it's really useful to have those to be able to solve when we are looking for the angle, rather than plugging everything into the original equation and then doing all those manipulations. If you just have those already written down, you can just quickly plug in. So our first example here, we're going to be dealing with the side, side, side case. We want to solve the triangle. So what I know is I have some triangle with our side lengths b equals 19, a equals 8, and c equals 14. Okay? So when I'm trying to do this, it's always nice to solve for the angle opposite the longest side first. But ultimately, it doesn't really matter. Okay? So using those kind of variant forms of the laws of cosine, I can say that cosine of beta, scroll up here, right? We can see is a squared. So it's a squared plus is a squared plus c squared minus b squared all over 2ac. So cosine of beta is equal to 8 squared plus 14 squared minus 19 squared all over 2 times 8 times 14. Now, it's really important, don't just jump into your calculator and do inverse cosine of this. You can, but it kind of, I really like to end up getting cosine beta equals what? And so in our calculators, very carefully, make sure you're doing this correctly or not. One of the most common issues is if you don't put parentheses around the numerator, is you'll end up doing 8 squared plus 14 squared. And then, so if you don't put parentheses around that in your calculator, depending on what calculator you have, you'll end up with something like 8 squared plus 14 squared minus 19 squared over 2 times 8 times 14, if you're not careful with your parentheses. All right, so if you just type in 8 squared plus 14 squared minus 19 squared divided by 2 times 8 times 14, this is what your calculator is going to think. So it's really important that you have parentheses around these pieces so that it actually takes that 8 squared plus 14 squared minus 19 squared, puts that in the numerator, and the 2 times 8 times 14, and puts that in the denominator. So hopefully that's not anything new to you. Hopefully you're like going, yeah, I know how to use my calculator, and that's great. So we put this in our calculator, we do some fancy mathematics with it, and what we end up with is a lovely little fraction, which is negative 101 divided by 224. Okay. And if you want to rock that as a decimal, it's not a very nice one. It's about negative 4.5. Keep that as the exact form. Keep that as that fraction. Okay. So now what we do is we have that beta is equal to cosine inverse negative 101 over 224. Now, before we do this, I want to make a note right here. So what we're looking for here, the reason why I want to do this is remember that -1 is always less than or equal to cosine of x less than or equal to 1. So whatever this number here, we got -101 over 224. That number has to be between -1 and 1. If it's not, that means this triangle doesn't exist. You may be asking, like, how can that triangle not exist? Right? Side cases, that doesn't really happen, but there's other cases where it can. And so we have things like side angle side angle, stuff like that. We can run into some issues where the triangle doesn't exist, and we'll see an example of that later on. And this is kind of a nice place to kind of catch that, be like, oh, hey, look, this thing cosine of beta is -3. That can't happen. There's no triangle that satisfies this. We can see that -101 over 224 is between -1 and 1. And if you wanted to go to that decimal to help you visualize that even more, that's fine as well. Okay. So inverse cosine of -101 over 224, this, because I'm running out of room, is approximately 116.8. And that's degrees. Now, if we just wanted to find beta, we'd be done. But we don't. We want to solve this triangle, which means I need to find everything else. I could do law of cosines again, but quite frankly, law of cosines, as you see, is a little bit more involved. A lot more places for simple mistakes, especially calculator mistakes, which is something you really want to avoid, right? On a test, it really sucks to miss a problem because you hit a button wrong on your calculator and then not attach any work for it, and you get 0 points instead of anything. So to find alpha, I can use law of sines, which is sine of alpha over 8 is equal to sine of 116.8 over 19, right? So we just use the law of sines here, and we end up with multiplying by 8 on both sides. We end up with sine of alpha is equal to 8 times the sine of 116.8 over 19. So alpha equals the inverse sine of this. Inverse sine of 8 times sine of 116.8 over 19. So alpha is approximately 22.1. All right. So we know beta now. We know alpha. We use law of cosines to find beta. We use law of sines to find alpha. Now we're going to do a third way to find gamma. And we're going to use a simple fact that gamma is equal to 180 minus 116.8 minus 22.1. So gamma is equal to 41.1. And that's it. So notice we only had to use law of cosines one time because law of cosines is a little bit more involved. There's a little bit more going on. Law of sines is always easier if we're able to apply it. And even simpler than that is just some basic subtraction. So there you have it. There is that example. Okay, so if we have side, we can use law of cosines. We were not able to use law of sines for side because law of sines has an angle in each side of the equation. And so you have to know at least one angle to be able to apply the law of sine. So let's look at our next example here. In this example, we are given side angle side. Okay, so if we draw this triangle, okay, we are given B equals 3, C equals 9. We don't know what A is, but we do know that alpha is 80 degrees. Okay, so we can use law of cosines here. So we can't really apply law of sines, right? Because for law of sines to work, right, we have an angle and a side length equals an angle and a side length. We have to know 3 of those 4 things, right? Either 2 angles on one side or 2 sides on one angle to be able to do it. The problem here is we know 2 sides and an angle, but they don't pair up. So we would have something like sine of 80 over A equals sine of gamma over 9. So we have 2 unknowns in that problem. We can't solve that. So we use the traditional form of the law of cosines, which says that a squared equals b squared plus c squared minus 2bc times cosine of 80 degrees. So let me cosine of alpha. So plugging in what we know, this is 3 squared plus 9 squared minus 2 times 3 times 9 times cosine of 80 degrees. So just grabbing our calculator and doing an approximation on this. So we have 3 squared plus 9 squared minus 2 times 3 times 9 times cosine of 80. We get that that's approximately 80.62. Actually, instead of writing it like that, that's fine to do in your calculator. And then just square root of answer, so you keep the exact value. But what we can also do is avoid doing the cosine. So we'd have 3 squared plus 9 squared gives us 90 minus 2 times 3 times 9 gives us 54. So we get a squared equals this. So to get rid of that, we square root both sides. Now I don't have to worry about the plus or minus here for a very simple fact that we're finding a side length. We know that has to be a positive value. And so we plug this into our calculator and we get that a is approximately 8.98. All right. Now from here, just as we did before, we can just use our law of sines because now we know a. And so we can say that sine of 80 degrees over 8.98 is equal to, let's say sine of beta over 3. So we get sine of beta equals 3 sine of 80 over 8.98. Beta equals inverse sine 3 sine of 80. That was terrible. I hate that. 8.9, that's even worse. 8.98. So then using our calculator, we get that beta is approximately 19.2 degrees. And last but not least, we have to find gamma. Well, we know what alpha was. It's 80 degrees that was given to us in the problem. We have now found out beta. So gamma is 180 minus 80 minus 19.2. Therefore, gamma is 80.8. And that's it. All right. This is something that is 80.8 degrees. So these are really straightforward type problems, right? We figure out what thing we need to use the law of cosines to find. And almost every single time from that point on, we can now use law of sines. And then if we're looking for the angles, then from there we can use the simple angle calculation that the sum of the angles is 180. So now let's look at this one. Does a triangle exist that satisfies a equals 6, b equals 3, c equals 10? Okay. Does this exist? So let's draw some triangle. Say b equals 3, a equals 6, c equals 10. So we've got our alpha, gamma, beta. Again, remember I said I like to find the angle opposite the longest side first. So using the kind of variant of the law of cosine, we get that cosine of gamma is equal to a squared plus b squared minus c squared over 2ab. So cosine of gamma equals 6 squared plus 3 squared minus 10 squared over 2 times 6 times 3. Okay, so we have that cosine of gamma is equal to, now we just do this math very simply, so 6 squared, again, making sure you're careful with your parentheses, plus 3 squared minus 10 squared over 2 times 6 times 3. And we get the fraction negative 55 over 36, which is about negative 1.53. So, does this triangle exist? Right? If we need to go through and take the inverse cosine of both sides, you can. Your calculator is going to give you an error. But if we just think back to up here, cosine has to be between negative 1 and 1. For this problem here, it's saying that cosine of gamma is equal to negative 1.53. That is not between negative 1 and 1. So therefore, there is, say something like no solution, does not exist, say no triangle exists, right? Whatever the problem is asking for. But ultimately, it's no, right? Does a triangle exist that satisfies A equals 6, B equals 3, C equals 10? No is the answer to that. All right. Now, can anyone think of a reason why that would be true? Right? If we have 3 lines, we should be able to connect them, right? We just might have to extend them out. Well, if we think about this, I have C. This is C. And that is a distance of 10. Okay? So now in my red, I'm going to take A, and I'm going to go, here's A, which is 6. Now in blue, I'm going to do green. I'm going to do B, which is 3. I have this one left over, which means that no matter how I arrange these, I just end up with something that has a big gap and it is not actually a triangle. All right. Heron's formula for area of a triangle. I'm not going to drive this with you guys. I'm going to give you this formula and you guys just use it. It's going to be that easy. So if we have a triangle with side lengths A, B, and C, then the area of this triangle is equal to this massive square root of S times S minus A times S minus B, S minus C. Now, for those of you asking what in the world is S, S is the semi-perimeter. Okay, S is equal to A plus B plus C over 2. Okay, that's it. So, find the area of the triangle given the sides. A equals 8, B equals 12, C equals 17. So I need to find the area of this triangle. Obviously, I have sides. I'm going to use Heron's formula here. So the first thing to do is find the semi-perimeter. So find S. So that is equal to 8 plus 12 plus 17 over 2, which is equal to 37 over 2. So that tells me then that the area is equal to the square root of 37 over 2 times 37 over 2 minus 8 times 37 over 2 minus 12 times 37 over 2 minus 17. And all that's in our square root. Now, This is absolutely fine. You could type this out every time. You could also, this is a nice, here, the semi-perimeter is always either going to be an integer or something 0.5. So it's not like it's um, a crazy number that's something like a third or anything like that. You're going to have repeated decimals. So you could write this as the decimal, just 18.5. If 37 over 2 is hard to do or it is annoying. You could also save things as a variable. So to do that in your calculator, for those of you who are unfamiliar, now this is again 83s or 84s. So this is for TI 83, 84th. It's also not very dissimilar for other calculators. Just make sure that if you have something other than a TI 83, 84, that you look up the specific way to do this for your calculator. So to store a value, it's very simple. So first thing you do is type the value. Type the value. So in this case, we would want 37 over 2. And then you're going to look for the button value. And then you're going to look for the button that says STO and has a little arrow. Okay. You're going to press that button. And we press that button on your screen. So if you type 37 divided by 2 and press that screen, it's going to create a little arrow. And then what you want to do here is you want to pick any letter. So any letter on your calculator. And if you're not familiar or comfortable how to get to the letters, you're just going to press the alpha button and then pick one of the buttons that has that letter above it. So STO, and then you're going to hit alpha, and then you're going to hit just a letter. So any letter. So I'm going to store this as S because, hey, that's what we're doing. So on my screen, it says 37 over 2, then it has a little arrow, and then S. And then I just hit enter. And what that now does is that now anytime I press the button, put in the letter S into my home screen, it treats it as the number 18.5. So if I do something like, in my calculator, I go S times 2, it gives me 37 because 37 over 2 times 2 is 37. So what's nice about that is then when I'm looking over here to do this in my calculator, the square root of 37 over 2 times 37 over 2 minus 8 times 37 over 2 minus 12 times 37 over 2 minus 17, I can just do these S times S minus 8 times S minus 12 times S minus 17. I hit that in my calculator and I get that the area is approximately 43.5 square units. And that's it. That's the end of this lesson. I hope you guys took something away from this. For those of you who have already done the assignment for SEP 8.1, there was no area in there, which we talked about area, right? And just to remind you guys, we can also think of area is equal to 1/2 AB sine of gamma, 1/2 AC sine of beta, or 1/2 BC sine of alpha. So those are the three area formulas we created last time. So you can use those. There will be some area problems on this homework that I wanted to put onto this law of cosines homework so that you guys could have to decide whether you're going to use these formulas from the law of sines or you're going to use this Heron's formula. And rather than it being obvious which one you're going to use, because that's the one on this assignment, that's the one on this assignment, it makes it a little more of a challenge for you guys. I want you guys to be thinking about, okay, how am I going to use these? Which one applies? When does it work? So that's it, guys. And I'll see you guys for section 8.3.